Well, hello, hello. It is that time. Right now, 101. Definitely had to get myself situated. Had some really great phone calls today. Hopefully your day's going well. So, as usual, we're going to tackle a little bit of algebra. But what I am going to try to do is let's get a nice quick refresher. Okay? Let's get ourselves math-minded, shall we? Mighty Glow, hello. Welcome, everyone. All right, so let's get a quick refresher. So we are solving inequalities. So we looked at interval notation yesterday, but let's take a look at how we are going to solve 7x minus 3, which is greater than 3 times x plus 1. All right, so let's see if you could take a guess. Okay, I like doing these things. Let me slide this down a little bit so I can get myself acclimated a little bit. And then plus I can zoom in quite a bit. Okay, hello. All right, so we have 7x minus 3 is greater than 3 times x plus 1. So if you could take a guess, what would the first thing you would do besides pray? I was like, I will pray to the heavens. I know. But in addition to praying, what would you do to solve this inequality? Okay. Hello, Paco. Thank you. Welcome in, Forever Young. Hello, Nika. Thank you so much for the like. I appreciate it. So, what are we thinking? What are we thinking? What can I do first? I'm hoping you're doing well, Paco. I see you pop in once in a while. Okay. Yes, Leanne, she's here. Apple user. Rewrite it. Okay. So how would you rewrite it? What do you mean? What would be the first thing you would do? Hey, Zach. Okay. Add 3 to each side. Well, something before that. Yay! I just messaged you earlier today. I just got you a little text. All right. So we're going to distribute this 3. Okay. We want to do that distributive property. Get rid of those parentheses. So we got 3 times x, which gives me 3x. And then bring down the plus sign. 3 times 1 gives me 3. All right, so now everything else is coming on down, including the inequality sign. So 7x minus 3. All right. Hello, Cheyenne. All right. I know I'll respond after this. Okay. So now, Paco, this is what we're going to do. We are going to add that 3 to both sides. So we can add 3 here and add 3 here. So when we do that, we have negative 3 plus 3. That cancels out. So then you have your 7x is greater than 3x plus 6. Okay. Hey, Savannah, not a problem. All right. Okay, gotcha. Good. Yes, the cat. The one of a couple. Yeah, I know. You were just passed out. You want to be famous? No? Okay. Just come on in. All right. So you are doing the Lord's work. I am trying. Woo! Lord, I'm trying. All right. So first we started off. We had to do the distributive property. So 3 times x, that's where 3x came from. Then 3 times 1, that's where 3 came from. So now we're trying to isolate our variables. So we made the suggestion of adding 3 on both sides. -3 plus 3 cancels out, but 3 plus 3 gives me 6. So now we're trying to get our x's on the same side. So what we do now, we would love to combine like terms, but this inequality sign is in between that. So that means we have to do something to this 3x to get it close to that 7x. Yes, Clarissa, how are you? So we're going to subtract our 3x. I haven't seen you in a minute. How are you? Okay, so when we subtract that 3x, now we got 7x minus 3x gives us 4x. And we bring down the inequality sign as well as bring over the 6. All right, good. So who's a better mathematician? Not working on that right now, Rob, please. All right, hello, Lisa. How are you? All right, so we have 4x is greater than 6. All right, are we trying to get the variables and numbers on each side by themselves? Yes, we're trying to isolate. That means we want to get our x by itself on one side. It doesn't matter which one. And then our constant, okay, the one that doesn't have an x or y on the other side. Okay, good. I would have divided 3 on both sides. I would have divided that 3 on both sides. Divide it, not divide it, we will have to subtract it first, okay? Okay, so now we are going to divide both sides by 4. Okay, yes. Okay, so now since we have 4x, that means 4 times x. So if you do 4 times x, you have to do the opposite. The inverse is division. So 4 divided by 4 will give me 1, but we still have an x. So we got our 1x. Now, 6/4. 6/4. That can be reduced. Someone had it as a decimal, but it also can be reduced. What can 6/4 be reduced by? There we go, Lisa. There we go. All right. I see my ladies. Good. Good. Because they both have a 2 in common. They're both even. So if they both have a 2 in common, 6 divided by 2, that will give me my 3. And 4 divided by 2, that will give me my 2. Okay, so that means my x, we got 3 halves. If you want to, I'm going to write the word or it's going to be x and 1.5 if it is represented as a decimal. What about the inequality sign or a mixed number? Okay, what about the inequality sign? Is it going to stay? Does it turn to equal? No, it doesn't. Once it's an inequality, it stays an inequality. Okay, I just put the equal here just so you can see that 6/4 is equivalent to 3 halves. But once it's an inequality, it stays an inequality. Okay, so I have stays the same, remains the same, flip it because you divide it. No, stay, because it's not a negative number. There we go, Leanne. There we go, ladies and gents. All right, so if you recall, we started off with a, wrong color, greater than. It only changes direction if you multiply or divide by a negative number. All right, so we divided by a 4, okay, a positive 4. So my inequality sign is going to stay exactly the same, regardless of what you use for your final answer. So all 3 of those can be represented. All right. Most examinations, you might see it as a fraction or you might see it as a decimal. Very rarely you'll see it as a mixed number, but that is also an option as well. Okay. Thank you so much for the follows, guys, and the likes. I appreciate it. All right. So why do you divide by 2 there? Because I'm reducing it. Okay. 6/4 needs to be reduced if I need to simplify it. So 6 and 4, they both have 2 in common. So they're both seen in the 2 times table. I really want to me a math teacher. You really want to me a math teacher? Do you want to be, you really want to be a math teacher? Okay. All right, so just get all your certifications. There we go. Thank you. No problem. I'm hoping I'm not insulting because sometimes my mind and the way I read things just kind of goes a little cray-cray. Yeah, so if you want to be a math teacher, be a math teacher. Go get those classes. Go to community college, start out there. Go with all the classes that you need to get, and then make sure your classes are transferable. I was typing too fast, yes. The common numbers is hard for me to know. So that's one thing you're going to have to know. What is in common? So the way that you know it is through the multiplication table. I'm just going to have to be real with you, okay? So that's what's happening with a lot of students because years ago, when I was a student, many, many moons ago, we used to do the cadence. We used to do, okay, today, class, we're going to do the 2 times table. And it was like 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. That's all we did. Like, that's all we did. But they don't do that anymore. So instead, they brought this lovely item into the classroom to take care of the multiplication and the division. But then guess what? Now, a lot of people just don't know how to do, or they're very minimal into how to solve things through multiplication. Because multiplications is mostly fast math, right? Okay, not me loving math, but never having memorized my times tables. I just count. Yes, but see, sometimes you're going to need to know those numbers really quick. Because I always see the people that always like look at you and then they look up in the sky like, okay. And you can see their mouths like mouthing and they're counting by 3, by 3, by 3, by 3, by 3. And you're like, dude, what's 9 times 3? Okay. And they go 9, 18. And they're counting on the fingers. Sometimes you just know. I know. If you know, you know. Right? Okay. By putting fingers down. It's true. Okay. Good. All right. So that is just going with the solving. Now, if I were to graph this, I'm just going to do a single number line. I'll use your 1.5s. Now, I taught people about bonded and unbounded. Now, since x is greater than 1.5, it's not including 1.5, okay? It's not including it. So when it doesn't include it, we have a parenthesis. Because parenthesis, remember, a lot of people used to do open circles, closed circles. But as you start advancing up, they're not using open and close. They're using what's called interval notation. So since it's not equal to, it's not including that 1.5. But it says it's greater than 1.5. So that means you are shading everything that's going to the right because all your numbers are increasing to the right when you're on the x-axis. And you're going all the way to positive infinity. Okay, so there's no stoppage. There is no boundary. Okay, that's why this is unbounded. So if I wanted to write it as an interval, I will start with my lowest number because 1.5 is definitely less than infinity. All right. So I start with my 1.5 and it's going to be a parenthesis, meaning it's unbounded, it's not including, and it's going all the way to infinity. Now, infinity is never bounded, so it's always going to be a parenthesis. And this is called interval notation. Okay, so that's what we were working on yesterday. Okay, good. We remember the parenthesis to the right. Good. 1.5 to infinity. Yes, the infinity shows that any number higher than 1.5 is a solution. Yes, Mel. Okay, anything. Okay, it could be 1.75. It could be 2,658. All that. Okay, I think it's algebra. Yes. Is this geometry? No, algebra, Mary. All right, this is going to be algebra. Okay. Okay, so we're dealing with algebra. Okay, so that was a little refresher. Now, not a problem. So now we're going into what's called compound inequalities. And you're probably like, oh, here goes Audrey doing some stuff. Yes, this is what I do, boo-boo. Wait, is the negative 1.5 not included? No, because why? There isn't a negative 1.5, okay? My answers were all positive, okay? So we're just looking from starting at positive 1.5 since it's greater than, it's not less than. So it didn't change inequality signs. So it's just dealing with positive 1.5. No, because x is greater than, okay, thank you. Oh, I see. Okay, all right, no problem. No problem. All right, so compound inequalities. Now I kind of made a hint a little bit for those that weren't here or those that were here yesterday. So compound inequalities, we need to work from the inside out. What a compound inequality is, you're merging two inequalities into one statement. And it always goes from the left is your smallest number and to your right is your largest number. Okay, it's always going to follow small to large. Oh, no problem. You're not bad at math. It's just the experience you had. Okay, so we're going to try to defunk that. Okay, why are you scared? I keep saying this. This is not Squid Games. You're not going to die. Okay, we're not going to, oh, you got that wrong. Done. All right, we're not doing any of that. But here's the thing. Yes, Miss Homebody, she's got that first part, okay? So when you're merging two inequalities into one, you always want to work from the inside out, okay? So what I mean by that, let me zoom in. So we have negative 4 is less than or equal to 5x minus 2, which is less than 7. So we want to get our variable, okay, this x. We want to get this x by itself in between those inequality signs. That's the goal, okay? We want to isolate our variable. So like, I want to give credit where credit's due, like Miss Homebody says, we're going to get rid of this minus 2. And the way we do it is we do the inverse. And the inverse of minus is plus. So we're going to add 2 here. We're going to add 2 here. And we're going to add 2 here. Okay? So we're going to basically take on everything inside the middle and also the two ends. So what happens? Negative 2 plus 2, that gives me 0. And we don't have to put the 0 because it's a placeholder. But what we do have in between my inequalities is my 5x. Okay? Since I just added 2, my inequalities are exactly the same. But then we're just going to combine our like terms on the ends. So negative 4 plus 2, that gives me a negative 2. Then 7 plus 2, that gives me a 9. Okay, how are we doing so far? I thought I was the only person who does math with a pen. Nope. Feeling a little risque, just on the edge. No. So for me, I like to use a pen because it shows up a lot better than, or shows up more than the pencil does. But you could be anyway. Okay, I forgot the minus again. Okay. So you owe me $4. You gave me $2. You owe me $2. So you're basically telling me don't borrow money from you, right? It's okay. All right. So now, okay, we got Too Tough Nikki. Hello, Too Tough. All right. And also we have, who else was there? The C symbol or the, I don't know, the symbol. All right. So what we're going to do is we're working from the inside out. So since it's a positive 5 and it's x, 5x means multiplication. The opposite of multiplication is division. So we're going to divide the middle and the two ends by 5. Okay. 5 divided by 5 gives me 1. But since there's an x there, I can just simply just write x. All right. Since we divided by a positive number, that means my inequalities are going to stay exactly the same. So I can bring down my less than or equal to over here and my less than over here. And now negative 2/5 and 9/5, the only things that they have in common is 1. All right. It's a moon. Okay. Thank you. So all I have to do is, since they don't have anything other than 1 in common, if I can't break it down, I'm just going to simply bring it down. Okay. That's my inequality sign. Kind of moved it a little too close. All right. So this is your answer. So we're saying that everything you do for this particular problem is anything between negative 2/5 up to 9/5, okay, is going to be your answer. But you can include negative 2/5. All right. And if you want to do, hello, Princess Two Spice, how are you? Yes, you can also put it as 1 4/5. That's fine. If you want to put it in its decimal form, that's fine as well. But when we're looking at, say, the number line, let me unzoom a little bit so I can give myself a little bit of room. So if I look at the number line, they ever ask me to graph it. All I have to do is just graph my ends, which is a negative 2/5. Remember, the negatives are to the left, and the positives is to the right. Okay. So since it is equal to, that means it's going to be a bracket. Okay. So anytime less than or equal to, greater than or equal to, it's always going to be a bracket. Whereas just less than or greater than, it will be a parenthesis. All right. The signs only change when you divide or multiply by a negative number, which we did. We divided by a positive number. Okay. Oh, never mind. Okay, no problem. All right. So the signs don't change when you divide. It only changes when you multiply, okay, when you multiply or divide by a negative number. So since we didn't divide by a negative number, the signs did not change. All right. So what's happening here, they're saying that negative 2/5 is less than my x, so it's dealing with numbers that are higher. And this is saying that x is less than 9/5, so it's dealing with numbers that are lower. So our answers are going to be right smack in between. Okay. Can you do it in 2 parts too? Yes, you can. Yes, you can. You can split it up if you want to. So if I need it in interval notation, remember it's bounded at negative 2/5, but it's unbounded at 9/5. Okay, so this is what it would look like as a graph. This is what it would look like as interval notation, and this is what it would look like as an inequality notation. It is. So if negative 2/5 is less than x, that means you're dealing with numbers that are larger. Larger numbers, remember, this is positive infinity over here, and this is negative infinity over here. So it is going to be showing to the right. Yes, I do read it like a book. Okay. Because if you want to split it up into 2 things by having your x value on the left, you can do that. Here you have x is less than 9/5. Then this one, you'll kind of switch it around, so x is going to be greater than or equal to negative 2/5. Okay, and I'm going to write the word and because it's composite. Let me see. Okay, oh, you need okay. Can you do an equation with fractions? I have, yeah, I'm not doing equations. All I'm doing is inequalities. Can you show me how to do linear and absolute value inequations? I'm not doing absolute values yet, but we're doing linear inequations right now. Inequalities right now. I do like that. Okay. Let's do another Miss Queen. Okay. Be my teacher. All right. So, again, we are... Okay, so we have, so that was example. Let's get with another example. So while I'm setting up, if you want to go ahead and tap the screen, I will greatly appreciate that. Then we have x minus 2. I feel like I'm doing this whole minus 2 thing. Okay. Okay, we can do it like that. Okay. Similar, but not quite. Let me see if I can raise it up a hair and zoom in a bit. Okay, so negative 7 less than or equal to 5x minus 2 less than 8. Okay. Okay, yeah, let's go. Inequalities with a fraction. We can do that. That's actually coming up. All right. So, what are we doing first? Let me see if I can. Not really. What are we doing first? Okay. Hey! I think. Got it. I think. Okay. All right. So what am I doing first? Yes, we got to think. Every time we see two inequalities, that means I got to work from the inside out. That means we want that variable by itself. So what needs to go in order for me to isolate my 5x? All right. So Lisa, what are we going to do with the 2 on both sides? Travis, what are we doing with the 2, guys? I'm seeing the 2. What are we doing with it? Yes, add, not subtract. Always do the opposite. Plus 2, good. So we're going to add 2 on all 3 parts. We're doing it on the ends, but we're also doing it inside. So what happens is my 2's will cancel out because -2 plus 2 gives me 0, but we don't need that placeholder because we already have our 5x. Okay, bring down my inequalities because I only added 2. What do I get on each side? Yes, we add 2 on each side. So what do I get on each side? The first number will be your left-hand side. The second number will be your right-hand side. Nice, nice. Okay, good, good. So -7 plus 2 gives me -5. Okay. You owe me $7. You paid me 2. That means you owe me $5. Here you have $8 plus 2. That gives you $10. Right? Good. So now, what are we doing next? Remember, we're trying to isolate our variable. What do we do next? Okay, I'm seeing divide by 5, divide 5. The outsides, we want to isolate our variable. We want to isolate that variable on the inside. So divide 5x, just the 5's. Okay. Hey, Tina. Okay, we're going with the 5. So that means we're dividing all 3 slots by our 5. Not the -5, but the 5 that's in between the inequalities. Because we want to work from the inside out. Okay. So yes, we want to cancel the 5 because 5 divided by 5 gives me 1. Or in this case, we still have an x. Are we changing the direction of the inequalities? Yes or no? And there's something missing, math magic, magician girl. There's something missing with the thing. Okay. So I got a bunch of no's because we didn't divide by a negative. Okay, now I got my no's. Yep, so right here, it's almost like it happens like close to the end. Sometimes it happens in the beginning, sometimes it happens in the end. But if I notice here, I'm dividing by a +5. So my inequalities are not changing. They're staying exactly the way they are. All right. Why do we divide as opposed to, well, 5x is multiplication. The inverse of multiplication is division. So that's why we divide instead of add or subtract. Okay, when you're solving, you're doing PEMDAS in reverse. Think about it. You're either going to add or subtract first, then you're going to multiply or divide next. Okay? So, over here, -5 divided by 5 gives me a -1. 10 divided by 5 gives me a +2. So now we basically have the answers. It's bounded at -1 because it's going to include -1, but it's unbounded at 2 because it's not going to include 2. All right, there we go, -1, 2. So if I were to graph this, let me unzoom a bit so you can see it, or a lot. Let me just unzoom the whole thing. So we come here, and we just put our endpoints. We put our bookends, as I like to call it. We have -1, and we have +2. So since it's equal to, that means it's including that -1. And if you want to switch things around, if you want to say, okay, x is greater than or equal to -1, and then the other inequality is going to be x is less than 2. If you want to split them up in order to graph them, do that, okay? You have things. And yes, at the 2, it's going to be a parenthesis. So you're shading everything in the middle. So that means anything including -1 but not including 2 in the smack middle will make this into a true statement. Okay. What has always confused me when doing these equations is not knowing when to divide or multiply. So if you look in between, if you don't see a plus or minus sign, that means you're multiplying. Always do the opposite, which is division. Why did you switch? Did I switch? Oh, I did switch. Oh, no, I didn't switch. The reason why, if you break this up into 2 inequalities, this one is saying -1 is less than. So if -1 is less than, that means the unknown is going to be greater than. So if you want to put it in a way that you can see the x, because we're so used to reading from left to right. So if you want to, you can make that x, switch that and make that greater than, and then put your -1. But the other one is going to stay exactly the same because x is less than 2. The x is on the left-hand side, so you can read it better. Okay, when do we use the filled circle? We're not, because now we're moved on to intervals. Okay, Peggy, hello. Yeah, once we moved into intervals, because this open and closed circles are usually for like pre-algebra, and then when you kind of get into algebra and into the interval notation, that's when you do the brackets and parentheses. So for those, if you have less than or equal to or greater than or equal to, you're going to use brackets. If it's just less than or greater than, you will use parentheses. Okay, not a problem. Okay, you did okay on that one. Nice. This is the only bracket parenthesis I was needing help with, but you sign trick helps me. Yes, not okay, good. You have to use open and closed circles. Okay, all right. But as long as you understand, less than or equal to, greater than or equal to, you can have the closed circles, but greater than, less than, open circle. Okay. All right. So interval notation, that means we're looking at -1, 2 with a parenthesis. Okay. All right. Next example, as promised. So we have -2 is less than 3 minus x over 2. Oh, what's she doing? less than or equal to 2. Let's see if I can raise that up a bit. It's okay, Tay. It is all right. Oh, guys are cracking me up. It's like the sigh, like, what is she doing? As soon as I get something, then something happens. Yes. That's what we do. We mess with your minds. But at least I'm one of those type of teachers that what we do in class, your homework is going to reflect that. And I might give you like one question that will give you a little challenge. But I've always hated when you're like, okay, you think you got it. And then the homework looks nothing like what you just did in class. And you're like, wait, where is this coming from? And then the next day the teacher's like, oh, I just wanted you to ad-lib a little bit. This is my first day. Don't be ad-libbing. It's like all that. I gotta wait for you on this one. Okay, not a problem. All right, so, yes. Okay, some of you guys got that. So remember, we are working from the inside out. So in between, we have a fraction. Fraction means division. What's the inverse of division? Hey, California living. What's the inverse of division? Multiplication. The inverse of division, the opposite of division, is multiplication. So to make things easier, we're going to multiply all three sides by whatever your denominator is. The reason why I always multiply whatever the denominator is because I can get rid of the fractions so much easier that way. Okay? Because when I multiply it, it's really going to be 2 divided by 2. Like these 2's are going to cancel out. And what's left in between is going to be my 3 minus my x. Okay? The reason why I multiply by whatever the denominator is so I can get rid of that fraction, and now I have 3 minus x. But over here, I have 2 times 2, which gives me 4. This came from here. Then over here, I have 2 times negative 2. That gives me negative 4. That's where that came from. Now, I multiplied by a positive 2. That's why I multiplied all three of those sides to. That means my inequalities are not going to change because I didn't multiply by a negative. Although I multiplied the negative 2, but I did not set it equal or set it up with a negative 2 in red. It's only a positive 2. So my inequality signs are going to stay the same. Okay, rules of formulas are important. Yes. Okay, just remembering some of those processes. I know it can be difficult. Trust me, I understand. Okay, how are we so far? Because that was just one step that was different from the others. Hey, Lynette. So how are we feeling? Okay, I got a couple hearts, so there's some heartbeats in here. Okay, hello, Carlos. Jojo. Okay. The cat's like losing his mind. I don't know why. He's fed. I don't know. I guess he wants to fight a cat outside. That's the story of my life. My cats are so aggressive. They learned it from their mama. Just kidding. Okay. Now, do we divide by 2? Shh. Hush. So we're actually going to subtract because we're going to work in between. working from the inside out. So that means we're trying to isolate our variable in between. So since we have a positive 3, this minus sign is attached to the x, not to the 3. Signage is always to the left of the number. So since that's a positive 3, we're going to subtract 3. And we're going to subtract 3 from all 3 areas. 1, 2, 3. Okay. Yes. All right, okay, but I will refresh my beginning stage. Okay. So 3 minus 3 gives me 0, and I don't need to put the 0 because I still have this negative x in between the inequality sign. Since I just subtract the 3, that means my inequalities are going to be the exact same. But what do I get for my ends? Okay, what do I get for my ends? The number on the left will be the first number. The number on the right will be the second number. Okay, so I got negative 7 and 1, negative 7 and 1, negative 7 and 1, negative 7 and 1, 1 and negative 1. Okay, careful. I think it's cat. All your problems for X. Hey, it's ditto. That's why yesterday was crazy. Anyway, so we have negative 4 minus 3. All right, you owe me $4. For some sick and twisted reason, I loaned you $3 more. So that means you owe me $7. Okay, I have $4 and I spent $3. That's why I only have $1 left. Okay. And make sure that 7 is a negative 7 because you're in the negative. You're owing me money. Okay. So the signs have to change. Okay. Same difference, California. Same difference. Okay, makes sense? Okay. So now, a lot of people think, okay, we're done. Go ahead and box that, Audrey. No. All right, we have a negative that's here. This is assumed to be not just a negative x, but it's assumed to be a negative 1x. Okay? So we need, since there's no plus or minus sign in between the 1 and the x, that means we need to divide. And we need to divide all 3 sides by negative 1. Okay? And it's just like what Lisa was saying. She says divide by negative, so the signs have to change. Okay? So if I'm dividing, my negative 1 and negative 1 cancels out, leaving me with my x. Don't want that. All right? Then we have, since we divided by a negative 1, this less than is now turned into greater than. This less than or equal to is now greater than or equal to. Negative 7 divided by negative 1 is a positive 7. 1 divided by negative 1 is a negative 1. Okay? So as long as x is by itself in between, we basically got our answers. But why don't I want to box this? Why do I want to box it just yet to say that it's my final answer? Okay, why do I not want to box it yet? I kind of made a helpful hint earlier. I know it's a little disadvantage for people that came a little bit later. But taking a look, why do I want to say, oh yeah, that's my answer, and just box it? You can put question marks. I accept question marks. You're like, I don't know. I just don't like IDK, but, you know, I'll suck it up and deal with it. Okay, because it is greater or positive. Okay. You're kind of right there on the cusp. Shay, thank you for being honest. She's like, question mark, question mark. Tiffany, because smallest is on the left, okay? When you're dealing with inequalities, if you ever noticed, let me scroll down for a little bit. We had -1, we had 2. -1 is smaller than 2. -2/5 was smaller than 9/5. And there was something else. I think it was the back of this. No, it wasn't. It was something else. Okay? So we want to kind of flip that around. We want our -1 to be on the left, my x obviously in the middle, and my 7 on the end, because I want to go from smallest to greatest. So when I do that, what do you think happens? This is now less than or equal to. This is now less than. You okay, babes? You're allergic to yourself? What's going on? All right. The reason why the less than or equal to, it came from here and I had to bring it here. So it goes extreme, came over here. This sign comes here. The x in the middle. Then this comes over here, switch. Then this comes out here. This is my official answer. Okay? It always goes from smallest to largest. All right? So if I were, I'm not even sure that's English, to graph it, remember my smallest, -1, my largest, 7. Okay? All right, give me one moment and I'll make it bigger in a second. All right, so yes, there is going to be a bracket at the -1. And there is going to be a parenthesis at the 7. So since we're saying my x values are going to be bigger and include -1, shade. Since we're saying my x value is going to be less than 7, shade. So they're meeting here in the middle. This can help us with our interval notation, which is -1, 7. Okay, so let me shrink it ink. Okay, let me kind of see if I can put the whole page. I know it's kind of hard with comments and all that stuff in the way, but try your best. Let me know if I have to like push up. Okay. So if you want to screenshot this, go ahead and screenshot it. If you need for me to push up. Okay. Clear display, you guys. Okay. All right. Too much? Okay. You guys, and the comments will go away. Oh. Well, thank you for the helpful hint. So clear display, you guys, and the comments will go away. Okay, perfect. All right. Okay, so we're going to do one more as a fraction. Let's see how you guys do. All right, so I'm going to put it right here, and it's going to be me staying silent, you looking over the notes and see if you can get your answers. We'll compare answers. All right, so we have 0, which is less than x plus 5 divided by 6, which is less than 2. Okay, tell me what my inequality sign or what my answers will be. Tell me what my answers will be. So I'm going to stay silent. We're going to put our answers up at the last minute. So I'm going to tell you when to put your answers up. Okay, so no hinting. I want you guys to try to work it out. Okay. Oh, no worries. I wasn't clear with the directions. Sorry, creature. But thank you for the helpful hint. So if anybody needs a hint, go ahead and take a look at the chat. All right, and I'm going to give you some time, and then I'm going to have you guys show your answers. Okay, I'm going to go over answers in about 1 minute. Oh, thank you. Well, congratulations on graduating. All right. Is this a precise function? Do you mean piecewise function? This is not a piecewise function. Compound inequalities. All right. Show your answers. Okay. Hey, Moody Nightfly, how are you? Okay, no worries. No tears. Yep, I got yours, Lisa. Okay. I know I'm wrong. How do you know? I feel like that show. How do you know? They're gonna know. How do you know? They're gonna know. No, they're not gonna know. Put your answers up here. Let's see what we got. So we have Shay saying -5 is 7. And if you're wrong, guess what? We make the corrections. Again, Squid Games. Not here. Everyone is gonna live, I hope. All right. All right. 24th, 18th. Okay. It's like, all right. I know there's what, 29 of us. So I got -5 and 7 with Tay. Shay gives me -5 and 7. Begonia, hello. J Young, -5 and 7. Sorry, lost audio for a bit. Okay, no worries. Well, hi. So I got -5, x and 7. Okay, a couple more. 2 more. Okay, 2 more. 2 more answers. 2 more brave souls. We got this. And if you're wrong, you're wrong. It's okay. And remember, I also take question marks as answers. Not necessarily after an answer that you give. So be strong with it. Okay, Tiffany, we have -5 and 7. All right, give me one more. One more, and then I'll go over. Okay. All right. Patience, Jae Young. Patience. I'm getting ready while I watch. I'm just here for the vibes. Not a problem. Okay, so we got Runaway Sisters at -5 and 0. All right, so now, hello, Jesus Range. So in between, remember, we're going to work from the inside out. So in between, we have a fraction. The inverse of a fraction is basically division. The inverse of division is multiplication. So we're going to multiply all 3 sides by whatever the denominator is. In this case, the denominator is 6. So there's going to be a 6 here, a 6 here, as well as a 6 there. All right? After I just said Jesus reigns and I'm over here doing 666 in red. Jesus. Okay, let's cancel out before things happen. So 6 divided by 6. There we go. They're gone. Whew. All right, we escaped something here. So now we have x plus 5. See how the devil just tries to just come in here? All right. So since we multiplied by positive numbers, we do not change the direction of the inequality sign. So now on the left, we have 6 times 0. Anything times 0 is 0. Okay. Then we have 2 times 6. 2 times 6, that gives me 12. Okay. All right. So now, okay. Awesome. All right. So now, again, working from the inside out. So we want to get x by itself in between the inequalities. So the opposite is going to be subtracting 5. And you're going to subtract 5 in all 3 spots. Okay. So when I do that, 5 minus 5, that will give me 0. So I don't need to put the 0 as a placeholder because I still have the x. All right. Bring down my inequality signs. And now I have 0 minus 5. That gives me a -5. And then I have 12 minus 5. That gives me a positive 7. So if I notice, my x is by itself in the middle. That's when I know when to stop. Okay, you don't have to divide everything by 1 because guess what? You're going to get this back. Save yourself a step. So we have -5 is less than x, which is less than 7. And then if we graph it, my ends is a -5, that's my lowest number, and the 7, which is my highest number. Since they're both less than, that means they're both going to be parentheses or open circles. And then your answer is right smack here in the middle. Don't make it a true statement. Okay. That's what I figured when I saw those. Good. Parentheses. Good. All right. Good afternoon, Mahogany. So lovely to see you again. So now interval notation. It'll be a parenthesis -5, 7 parenthesis. Okay. All right. Good. Well, then stop chirping. Coming at the end. Oh, that's easy, bro. No kidding, bro. All right. All right. So Miss Page, hello. All right. So that's what we're doing. When you're dealing with compound inequalities, let me see if I can zoom out for a second. So when you're dealing with compound inequalities, you got to work from the inside out. All right. So if it's in division, that means you're multiplying in all 3 spots. If it's, let's see right here. So if it's like this problem here, we had to add 2 to all 3 spots, and then we divide it by 5 in all 3 spots to get our answer. Okay, so you always got to work from the inside out. So you're either adding and subtracting first. Unless it's a fraction, that means you're multiplying first. Okay, I know. I saw you, brah. Want to know where I messed up? I multiplied 5 and 6. Yes. Okay. Yes. So the reason why you're multiplying by, I know it seems weird to put it there, but I had to squeeze it in. But the reason why you're multiplying is to get rid of the denominator. Okay. We were doing this multiplying to get rid of that denominator, so we don't have to worry about fractions anymore. All right. All right. So that is compound inequalities. We did a little bit of graphing. We did a little interval notation, just carrying a lot of these things over. Again, I am not going to be having my session tonight at 8:30 because I have tutoring for 8:30, but I will definitely be here tomorrow at 1 p.m. Eastern Standard Time to 2:15 at the absolute latest. Really, it should be 2 because I forgot I have another person. And then I will be there at 8:30 tomorrow night. Okay, so tomorrow night I will be available at 8:30. You do 1-to-1 tutoring? Yes, Shay, I do. Okay, I know. I know Moody Knight's like, why? I'm like, look, I love doing this, but I have to pay bills. So unless I'm going to be charging you guys for the lives, I have to take on clients so I can, eat, clean clothes, hair, basic necessities. They're talking about the temperature's going to drop again the end of this week. And I'm like, dude, I'm done. It's not going to be 9 degrees, thank God. But, my body wasn't ready for 9 degrees. At all. I don't think anyone is. Like, I have students in Alaska and they were laughing at me. They're like, we're used to that. And I'm like, I'm not. Okay, thank you. Definitely contact me later. So if you do 81, well, we're at 62 right now. And guess what my heat's doing? Nothing. I turned that thing off this morning. I was like, look, I'm putting a jacket on and that is it. Tired of this. So if anything, if you are interested in 1-to-1 tutoring, I do have some availabilities. I'm usually available 7 days a week, especially in the afternoons. But I know adults, you have mostly the free time in the mornings, which is great because I have a lot of openings in the mornings. And then tomorrow at 1 o'clock, we're actually going to be doing the absolute values inequalities. So we're going to work a little bit on absolute values a bit. And we're just going to take it from there. Leesburg, Florida. Oh, wow. Yep, Baltimore, Maryland. So tomorrow afternoon, it'll be absolute values. Tonight, what am I doing tonight? That's a really great question. I think I was doing intro to matrices, if I'm not mistaken, or systems of inequalities. I couldn't remember which one of the two. Oh, Buffalo. Ooh, yeah. All kinds of crazy weather in Buffalo. Y'all just gonna know. 1 minute it's fine, next minute it's like, whew, can't even talk about that. So that's what I'm gonna be doing with, and I think that's it. Does anyone have any questions? If you are interested, oh, here's another thing. If you're interested in courses, if you're taking your GED and you just need more practice, some more practice problems, I do have courses for GED, AccuPlacer, ASVAT, that is available. You just need to contact me so I can put you in, so you can get yourself started for that. The courses are $57, and I'm doing it as a membership. So this is what's happening. You pay for it, you get access to all the videos, the practice problems, the test questions, all that. And then if you get stuck, what I would do in the beginning, since a lot of people tend to come like a little bit later in the sessions, you give me your questions or your problems ahead of time. I will go over those in the beginning, and then I will continue on with whatever we're about to do. Okay? All right, yes, bipolar. I know. Disrespectful, I just like to say. Okay, so if you ever want that, you can follow me here on TikTok. I'm also on YouTube under ACG Math Tutoring. And if you like the format of this, that is actually a part, because I'm waiting for my other books to arrive, a part of a notebook that I created. So it's a math notebook, just like a regular notebook, but it's designed for math students. And this one's designed from 7 through adults. So you have the room, you have the dot drill, you have basically your formula section as well as the steps. And on the other side is the grid paper. So if you need to do extra practice problems or even extra graphs, you can do so as well. So like I have it over here. In addition to the space, as I like to call it, the Cornell space, I have a resource section. So if you're not very good with multiplication, you are going to need this factor sheet. I have factor sheets from 1 to 200. Okay, so you can get to know your factors, especially when you get into factoring. We're going to be doing some of that. Breaking down radicals, that's going to be involved. So any of those things, this is really going to help you out. Okay, and it also gives you a couple other resources as well, just to remind you. And then it gets a little advanced with some of the trig, and then also the circle formulas, as well as the unit circle for my Algebra 2 people. In addition, we always get some brain breaks. Sometimes we need a brain break that does not involve our phone. We just need a moment of mindless scribbling. And if you're into pixel art, you can draw pixels here or do a little sketching there. All right. So this is available on Amazon. Okay, you can get it through, the link is actually through my website. If you click on my picture for my profile, you can go to my website and you can just get me through there. Okay, all right, not a problem. So again, if you know anyone that is like having trouble with math, I do basically from Algebra 1 up to college algebra, especially those intermediate classes that some people are taking when they go back to school, and they just wanted to basically get themselves out of those basic classes. All right. So I think that's it. I think that's it. I think that's all I can do. But if you do need me, do not hesitate to message me, okay? Please. You need the assistance, go ahead. If you want to do more math, you can go to my friend at Impact Math 19. She's live right now, and she does like more of the math problems, more of the word problems as well. And especially if you're taking some of those tests. And I think that's about it. Yeah, that's about it. So if you want to hop on over there, you can. Do I do private tutoring? Yes, I do. If anything, just go to my profile, go to my website, and you can fill in the contact form. It's really quick and easy, and I'll get back to you sometime today so we can get ourselves situated ASAP. All right? All right. Yes, she is great. Yes. Yes, definitely go over there to Impact Math. Not a problem. And that's the one thing about me. I do not like to be selfish. I like to be surrounded by good and great people that are thinking about your benefits. Okay? So I'm going to hop off here. You guys can go to Impact Math 19, and I will see you in a few. I'll see you guys tomorrow morning or tomorrow afternoon at 1 p.m. All right. Take care. Bye.